TechNerds are presenting the problem statement approach which we have built in the DoseHack. The primary challenge we set out to solve was how to efficiently guide multiple autonomous boats across a warehouse grid while avoiding obstacles and each other. We approached this by employing the A pathfinding algorithm, which is A star is ideal for navigating grid-based environments as it finds the most efficient path from point A to point B by calculating both the actual cost to move and estimate distance remaining. By doing so, each boat could take the shortest path from its straight point to its designated goal. But navigating also wasn't enough. We also needed a way to visualize and monitor the boats as they moved in real time. So we developed a TechInter based graphical user interface. This allowed us to see each boat's movement, directions, and interactions with obstacles and other boats. One key aspect of our design is collision detection and avoidance. Since multiple boats are moving through the grid simultaneously, the chances of collision are high. To solve this, we added a mechanism where each boat checked for potential collision before advancing. If two boats are about to collide, one boat will wait until it's safe to proceed. If a boat waits for too long, it will reverse and recalculate an alternative path. This prevents deadlock and keep the system moving efficiently. A major part for this project involved addressing edge cases like deadlock and dynamic obstacles. Let's start with deadlock, which happen when two or more boats are stuck waiting for each other to move. Our solution track how long each boat waits in one place. If a boat waits beyond a certain threshold, it reverses its last move and recalculates a new path using the A star algorithm. This prevents the boat from remaining stuck in the same position for too long. In future iteration, our system can also handle dynamic obstacles, meaning obstacles that move around the grid. While we design our current system for static obstacle, we can extend it by updating the grid and rerunning the pathfinding algorithm dynamically. Now I'll give a quick code walkthrough of the core component of our project. The A pathfinding algorithm is the heart of this system. The function A star all path calculate all possible paths for each boat, considering both the cost of each move and heuristic to ensure the paths are efficient. Grid initialization. The grid is represented as a 2D array where each cell could be an empty space, obstacle, board, or goal. This is initialized by the function createGrid. The board movement logic happens in the updateBoard function. This function checks for collision, handle waiting, and tracks movement for all boards. Lastly, the tkinter GUI is rendered using functions like drawGrid function and drawArrow. This function ensures that the user can visually monitor each board movement in real time, seeing the current position, obstacle, and boards. Now I would like to give you a brief overview of a live test case to demonstrate how our system works in real time. During the demo, you'll see the boats starting at their respective locations and navigating towards their goals. The A pathfinding algorithm will help them choosing the most efficient paths, avoiding obstacles and each other. If two boats approach a collision point, you'll notice one boat will wait to prevent the crash. And if that boat waits too long, it will reverse the recalculate the new path. So multiple path calculation, the A star algorithm doesn't just calculate one path but consider multiple potential paths, allowing the boats to adapt when needed. Real-time collision and deadlock handling. Our solution uses a combination of weighting and path recalculating mechanism to avoid deadlock and collision in real time. This is also user-friendly interface. Our TechIntel GUI provide an intuitive and clear way to monitor the boat's movements. It makes the entire process transparent and easy to understand for users who may not be familiar with the underlying algorithms. These are all the test cases. Before we wrap up, I would like to give a quick overview of how our team worked together to make this project successful. Our one team member worked on the A pathfinding algorithm, ensuring that the boats could navigate the grid efficiently while avoiding obstacles. Our second team member designed and developed a Tkinter based GUI, which allows us to visualize the boat's movement and interactions in real time. A third team member implemented the boat movement logic, including handling edge cases like deadlock and developing the waiting reversing mechanism to avoid collision. Thank you.